Hello everyone. We will study secure and dependable computing today. Under this we will go on to introduction of cryptography. Then we have terminology, basic encryption methods and one-time pad under this. Next topic we have today is symmetric key algorithms. Under this we have DES, AES, etc. Let's see what is cryptography terminology. Encryption is the process of encoding a message so that its meaning is not obvious. Equivalent terms are encode, cipher. Decryption is the reverse process transforming an encrypted message back into its normal original form. Equivalent terms for decryption are decode, decipher. Plain text message to be encrypted. Ciphertext is encrypted message. Cryptography terminology. The crypto system involves a set of rules for how to encrypt the plain text and how to decrypt the ciphertext. Why encryption? It addresses the need for confidentiality of data, also helps to ensure integrity. It forms the basis of protocols that enables us to provide security while accomplishing system or network tasks. The encryption and decryption rules are encryption and decryption algorithms. Encryption and decryption algorithms often use a device called a key, denoted by K, so that the resulting ciphertext depends on the original plaintext message, the algorithm, and the key value. An encryption scheme that does not require the use of a key is called the keyless cipher. Symmetric encryption. The encryption and decryption key are the same, so P is equals to D. D and E are closely related. They are mirror image processes. The symmetric systems provide a two-way channel to their users. The symmetry of the situation is a major advantage of this type of encryption, but it also leads to problem key distribution. D of K, E of K of P is equals to P. Here we have passive intruder just listens, and one active intruder can alter the messages. How it works for this process, we have the user will give its plain text or any data that is in the form of plain text of P. It will have the encryption method that is called as E. Then it will go to the ciphertext, then it will become a ciphertext. We will call it as CE, which will become E of K of P. And it will again decrypt the message. First it will encrypt the message, then it will become ciphertext, and on ciphertext it will decrypt the method. It will work on decryption method that will be called as D, and then again it will give the plain text, the same text as we have given in the earlier stage. Now, asymmetric encryption. Encryption and decryption key comes in pairs. The decryption key K of D inverts the encryption of key A, so that P is equals to D, K of D, E, K of E, P. Asymmetric encryption systems excel at key management. Cryptology. Cryptology is the research into and study of encryption and decryption. It includes both cryptography and cryptanalysis. Cryptography is art of devising ciphers. Comes from Greek words for secret writing. It refers to the practice of using encryption to conceal text. Cryptanalysis is art of breaking ciphers, study of encryption and encrypted messages, hoping to find the hidden meanings. Cryptanalysis attempt to break a single message, attempt to recognize patterns in encrypted messages to be able to break subsequent ones, attempt to reduce the key in order to break subsequent messages easily, attempt to find weaknesses in the implementation or environment of use of encryption, attempt to find general weaknesses in the encryption algorithm. Traffic analysis, attempt to infer some meaning without even breaking the encryption. For example, noticing an unusual frequency of communication, determining something by whether the communication was short or long. Breaking encryption schemes. Ciphertext only. Cryptanalysis has a quantity of ciphertext and no plain text. Known plain text. Cryptanalyst has some matched ciphertext and plain text. Chosen plain text. Cryptanalyst has the ability to encrypt pieces of plain text of his own choosing. Basic encryption methods are substitution ciphers, one letter is exchanged for another, transposition ciphers, order of letters is rearranged. Substitution cipher. Idea: each letter or group of letters is replaced by another letter or group of letters. Caesar cipher: circularly shift by three letters A to D, B to E, J to C. More generally shift by K letters, K is the key. Monoalphabetic cipher: map each other to some other letter. A, B, C, D, E, F will become A to Q, B, W to Z will become M, and like this are the key to the A to Z letters. Cryptanalysis of substitution ciphers. Brute force. Cryptanalyst would have to try 26 mod permutations of a particular ciphertext message. Smarter way: use frequencies of letters, pairs of letters, etc., or by guessing a probable word or phrase. More frequently occurred letters ETOAN, digrams THINERREAN, trigrams THEING, AND, ION, ENT, words THEOFAND, like the, of, and, to, a, in, that. When messages are long enough, the frequency distribution analysis quickly betrays many of the letters of the plain text. Transposition cipher. Substitution cipher preserves order of plain text symbols but disguises them. Transposition cipher rearranges symbols but does not disguise them. It is also called permutation. With transposition, the cryptography aims for widely spreading the information from the messages or the key across the ciphertext. Transposition tries to break established pattern. Columnar transposition. Plain text written in rows, number of columns is equals to key length. Key is used to number the columns. Ciphertext read out of columns starting with column whose key letter is lowest. Columnar transposition. A transposition cipher example is this. So this is our plain text. Please transfer $1 million dollars to my Swiss bank account 622. Ciphertext for this will be this code written here. This is the ciphertext for this plain text. So this is the example of cipher. One-time pads. One-time pad construct an unbreakable cipher. Choose a random bit string as the key. Convert the plain text into bit string. Compute the XOR of these two strings bit by bit. The resulting ciphertext cannot be broken because in a sufficiently large sample of ciphertext, each letter will occur equally often, as will every diagram, every trigram, and so on. There is simply no information in the message because all possible plain text of the given length are equally likely. The Vernam Cipher. The Vernam Cipher is a type of one-time pad devised by Gilbert Vernam for AT&T. So it is the process diagram for encryption and decryption in Vernam Cipher. The Vernam Cipher is the encryption involves an arbitrarily long non-repeating sequence of numbers that are combined with the plain text. Assume that the alphabetic letters correspond to their counterparts in arithmetic notation mod 26, that is, the letters are represented with numbers 0 through 25, like A for 0, B for 1, C for 2, and so on. Hence we get Z for 25. To use the Vernam cipher, we sum this numerical representation with a stream of random 2 digits number. The Vernam cipher example is this. Our plaintext here is Vernam cipher. Its numeric equivalent is like A is at the 5th place, but starting from 0 we get the E for 4th place. So V is at 22 place, but starting from the 0 we get it at 21st place, and so on. And here we have our random numbers, and we will sum our numeric equivalent to random numbers, and we will do it mod 26. And the ciphertext here this is our ciphertext. So this is the encrypted text we get for our this plain text for Vernam cipher. So this row is our numeric equivalent, like A for 0, B for 1, C for 2, and this is our random number row. Here we have our sum of these two, this is, and we will do mod to this sum, and we will get this cipher for this mod. Like T is at the 20th place, so we get 19 for T, A for 0, H for 7, R for 17. Like A is at 0, so we get B at 1, and so on. So this is our ciphertext for this row. The Vernam cipher observations. The repeated letter T comes from different plaintext letters. Duplicate ciphertext letters are generally unrelated. When this encryption algorithm is used, there is no information in the message to be exploited. The Vernam cipher decryption. To decrypt CI to KI mod 26, note on rules of mod on negative number. The mod function is defined as the amount by which the number exceeds the largest integer multiple of the divisor that is not greater than that number. Modula OP always return non-negative number. For example, 19 minus 76 mod 26 is equals to minus 57 mod 26 is equals to minus 78 plus 21 mod 26 is equals to 21. The Vernam cipher decryption here we have is, so this is our last text we got in encryption, the ciphertext. This is our numeric equivalent for this ciphertext. This is one-time pad. Now this is the difference. In encryption we added, in decryption we subtracted, and same we'll do it mod. So we go in reverse in this, and finally we get our plain text. This is our plain text was Vernam cipher at the receiver's end. This is one-time pads. What are the disadvantages of one-time pads? The key cannot be memorized. Both sender and receiver must carry a written copy with them. Total amount of data can be transmitted is limited by the amount of key available. Sensitive to lost or inserted characters. Symmetric key algorithm. DES, the data encryption standard. AES, the advanced encryption standard. Other ciphers and cipher modes. Data encryption standard. Developed by IBM. Same key for encryption as for decryption. Encrypts in 64-bit blocks, uses 56-bit key, has 19 stages, 16 parameterized by different function of keys. Triple DES effectively increases the key length. It uses 2 keys and 3 stages. In first stage, the plaintext is encrypted using DES is the usual way with K1. In the second stage, DES is run in decryption mode using K2 as the key. The third stage, another DES encryption is done with the K1. So this is triple DES encryption, this is triple DES decryption. AES is the result of a cryptographic contest organized by NIST in 1997. Rules for AES proposals: the algorithm must be a symmetric block cipher, the full design must be public, key length of 128, 192 and 256 bits supported, both software and hardware implementation required, the algorithm must be public or licensed on non-discriminatory terms. Winner: Rinsdale. I hope you understood in this lecture. Thank you for watching the video. For any query, comment on the video. Please subscribe to my YouTube channel for more computer science subjects and insights IAS daily current affairs for UPSC 2021 preparation. Have a nice day. Bye.